So we're going to have a look at a differential equations question from 1979. We've been told that a body is moving in a straight line subject to a deceleration which is equal to v squared over 10, where v is the velocity. So we've been told that the deceleration is equal to v squared over 10, so we can say that the acceleration a is minus v squared over 10. The initial velocity is 5, and we want to know in how many seconds will the velocity of the body be 2 meters per second. And then the second part of the question, how far will we travel at that time? So initially what we're interested in is how long it will take to go from a speed or velocity of 5 meters per second to a velocity of 2 meters per second. So what we're going to do is we are going to change the a into a dv dt. So remember that dv dt is the change in the velocity over time, and obviously the change in velocity over time is equivalent to acceleration. So dv dt is equal to minus v squared over 10. We're going to collect the v terms on the left hand side and any t terms on the right hand side. So if I divide both sides by v squared, I have 1 over v squared dv is equal to minus 1/10 dt. We're going to integrate both sides, and I'm also just going to convert the 1 over v squared into v to the power of minus 2 so that we can use the power rule of integration to integrate that. I'm also going to throw in the limits of integration. We know that when the velocity is 5, the time is 0, and then we're interested in what's the time when the velocity gets to 2 meters per second. So integrating v to the power of minus 2, I'm going to raise the power, the v to the power minus 1, and then divide by the new power minus 1. And then integrating the right hand side with respect to t, I get minus 1 over 10 times t. Before we sub in the limits, I'm just going to convert v to the power minus 1 over minus 1 into minus 1 over v. So we have a minus on both sides, so I'm going to multiply both sides by minus 1, and then I'm going to sub in the limits. So on the left hand side I have 1 over 2 minus 1 over 5, and on the right hand side I have 1/10 on t minus 0. 1 over 2 minus 1 over 5 is 3 over 10 equals 1 over 10t, and then I'm going to multiply both sides by 10 to give me that t is equal to 3. So to go from 5 meters per second to 2 meters per second took 3 seconds. So the second part of the question says how far will the body travel in that time? So we don't have an equation with s's for distances and t for time, but we can make an equation or form an equation that has velocities and distances. And so instead of finding out how far the object travels from 0 to 3 seconds, we're going to find out how far it travels from moving with a speed of 5 meters per second to moving with a speed of 2 meters per second. And as before, we can say that acceleration is dv dt, but this time I am going to split dv dt into dv ds multiplied by ds dt. Now ds dt, remember, is the change in the distance over time, and another name for the change in distance over time is the velocity. And so we have a formula that says the acceleration is equal to v dv ds, and so that's the formula I'm going to use in this equation rather than in the previous equation where I used dv dt. So v dv ds is equal to minus v squared over 10. As before, we're going to collect the v terms on the left, and this time we're going to collect the s terms for distance or displacement on the right. So dividing both sides by v squared, I get v over v squared is 1 over v, and then that's equal to minus 1 over 10 ds. So I'm going to integrate both sides, and I'm going to put in the limits that I'm going to gather from the previous part of the question. We know that the displacement of the body was 0 when the speed was 5, and then we're interested in finding the displacement or the distance traveled when the speed got to 2 meters per second. So integrating the left hand side, 1 over v becomes the natural log of v, and the right hand side, minus 1 over 10 becomes minus 1 over 10s. I'm going to sub in the limits. On the left hand side, that gives me log of 2 minus log of 5, and that's going to be equal to minus 1/10 on s minus 0. Using one of the rules of logs, that the log of a minus the log of b is equal to the log of a over b, I can say that the log of 2 minus the log of 5 is the log of 2/5, and that's equal to minus 1 over 10s. So I'm going to bring the 1/10 s to the left hand side, and that's equal to minus log 2 over 5. And then minus log 2 over 5, we can change that to a plus log by inverting the 2 over 5. So 1 over 10s is going to be equal to plus the natural log of 5 over 2. I'm going to multiply both sides by 10 to give me that s is equal to 10 natural log 5 over 2. And then I'm going to throw this into my calculator to give me that the distance travelled is 9.1629 meters. So this is how far the object travelled in the first 3 seconds, but also we can say that it's the distance travelled whilst moving from a speed of 5 meters per second to a speed of 2 meters per second.